Okay, so in today's class, I'm going to start with the concept of position vectors. Position vectors are simply those vectors, simply means that you need to locate a point in space relative to an origin. Now, the origin is usually O. So if I draw a Cartesian plane, this is y-axis, this is the x-axis, and if I
Sir,
mark a random
screen
point
shared.
P, sorry, can you hear me?
Yeah, sir, is your screen being shared?
Yes.
Oh, okay, never mind. It's my end problem. I can see it now.
You can see it now? Okay.
Yeah, sir.
So if there's a point located and if I want to connect it with the origin O, then the vector OP is going to be called the position vector. The position vector of P simply means the vector OP. PO is not a position vector, only OP is a position vector. If I have another point A and if I connect that with the origin, the vector is going to be OA, the position vector of A. Now let's say I ask you to find the vector PA vector in terms of its position vector is nothing but OA minus OP. Do you know this?
Yes, sir.
So if you have the position vector of A and position vector of P, then you can just subtract it to get the vector PA. PA is going to be OA minus OP. A D vector in terms of its position vector would be OD minus OA. This is how you can write the position vector. This position vector is a fixed vector. Okay. So when we talk about three-dimensional vectors, let's say OA, there is a point A in space that has a coordinate of 1, 2, 3. This means that move x units, move 1 unit in the x direction, move 2 units in the y, and move 3 units in the z direction. OA vector is going to be written as 1, 2, 3. That is the position vector. And in terms of I, j, and k, OA can be expressed as 1i plus 2j plus 3k. These are the unit vectors. I, j, k are the unit vectors. So I vector is in the x direction, j vector is in the y direction, and k vector is in the z direction. Okay.
Sir, I didn't understand this part.
Which part?
Of the I and J vector.
I, j, and k. Okay. So, for example, you have this three-dimensional plane. This is your x-axis, this is your y-axis, and this is your z-axis. So if I draw the unit vector in the x direction is the I, the unit vector in the y direction is j, and the unit vector in the z direction is k. Okay, so if a point is such that one OA is 1, 2, 3, and so that means you have point A is located at 1 unit in the x, 2 units in the y, and 3 units in the j direction. So let's say if I mark this point A over here, this point can be reached by traveling 1 unit in the x, 2 units in the y, and 3 units in the z direction. So you're going to get the vector. So if A was 1, 2, and 3, these were the coordinates. Then the position vector OA, this is O, the position vector OA in 3 dimension is going to be written as 1, 2, 3 as a column vector. And in terms of I, J, and K, 1I plus 2J plus 3K. So I, J, K are the directions, and X, Y, Z are the scalar values. So this is basically Xi plus Yj plus Zk. So X is 1 over here, Y is 2, and Z is 3. IJK are the perpendicular vectors. These are the unit vectors in the X, Y, Z direction. So any point, for example, if there was a point Q that had a coordinate of 4, 2, 3, then the position vector of OQ is going to be 4, 2, 3. It can be expressed as a column vector, or the position vector can be expressed as 4I plus 2J plus 3K. Is it okay? Clear?
Yes, sir.
Sure?
Yes.
Okay. So let us also discuss position vector of any point in a plane. So a plane is a two-dimensional space. So if I am marking this point O, and vector A is in this direction and vector B is in this direction, this is A and this is B. So, okay. But there's a point P somewhere here, and if I connect point P with O, I'm going to get a position vector OP. Now, if I ask you to express OP in terms of A and B, you can see that a parallelogram can be formed. To go from O to P, you will have to travel from O to this point and then from this point to P. Would you agree with that? Vector addition.
Yes.
But only this line, this blue line, is representing vector P. So this complete line, the vector in over here, is going to be some scalar number of B. So you can say that this is some scalar number times B, and if just this part is vector A, then this part is going to be some scalar times of A. This, it's a parallelogram. Remember, parallelogram has equal opposite sides, so the vectors, opposite vectors, are going to be parallel and equal. So if this is, whatever is this vector is also the same. So if this vector is m times a, then this vector is also going to be m times a. Now, if I ask you what is vector OP, you are going to say, so travel from O to this point, and then from this point go to P. So OP is the sum of MB. I should change this scalar number. Let's say NA, some scalar number, plus NA. Okay, so this vector OP is equals to MB plus M times P plus N times A, where M and N are scalar values only. Do you understand this?
Yes, sir.
Now let's try a question so that things are further clear. If I tell you that uh, the position vector the position vector of A is expressed as A, the position vector of B is expressed as B, and the position vector of point C is expressed as C, where A, where vector A is 2, 5, minus 3, vector B is 0, 4, 6, and vector C is minus 4, 2, 24. The first part says write A, B, and C in terms of I, J, and K. So if I want to write the vector A in terms of I, J, and K, would you agree that it is going to be 2I plus 5J minus 3K?
Yes.
Vector B is going to be 0I plus 4J plus 6K. And vector C is going to be minus 4I plus 2J plus 24K. Right?
Yes.
Okay. Now A was a position vector of point A, so that is OA. B was a position vector of B, that is OB, and C is a position vector of C, that is OC. If the next part says find, uh, giving your answer in terms of I, J, and K, find vector AB and vector AC. So do you agree that vector AB in terms of its position vector is going to be OB minus OA? Can I write AB vector in as OB minus OA?
Yeah.
So OB is 0I plus 4J plus 6K minus OA, that is 2I plus 5J minus 3K. You just now when you are solving this or you are simplifying this, the I component can only be added or subtracted with the I component. The J component can be added or subtracted together, and the K components can be added or subtracted together. So 0I minus 2I, okay, is going to give you minus 2I, plus 4J minus 5J is going to be minus J, plus 6K minus minus plus 3K is going to give you plus 9K. Is this making sense?
Yes, sir.
Okay. Now vector AC, what do you think AC, how can AC be expressed as in terms of its position vector?
Uh, OC minus OA.
Great. OC minus OA. So OC is minus 4I plus 2J plus 24K minus OA, that is 2I plus 5J minus 3K. So minus 4 minus 2I is minus 6I plus 2J minus 5J is minus 3J plus 24K plus 3K is plus 27K. This is your vector AC. Make sense?
Yes, sir.
Okay. Now the next part for the same question says describe the relationship between points A, B, and C, justifying your answer. So you need to describe the relationship between point A and point A, B, and C. So AC, previously AC vector came out to be 6I minus 3J plus 27K, and vector AB came out to be minus 2i minus j plus 9k. Okay, now you can see that if you take 3 common from vector AC, what do you get? Minus 2i minus j plus 9k. What is this vector equal to?
AB.
AB. So if AC is 3 times AB, what can you say about the two vectors AC and AB?
The parallel?
They are parallel. So AC and AB are parallel. Okay. Now AC and AB are parallel, but they have a common point. The only way they can be parallel is when they share a common point and all the points are on the same line. Do you get it? They have a
Yeah.
common point A. So what can you say about the points? You can say that point A, B and C are collinear points because they have A as, because A point is common. Collinear means the point, all the points are lying on the same line. So if you are asked to show whether the points are collinear, then the vectors must be parallel, and for the vectors to be parallel they must be scalar multiple of each other and they should have a common point. Is this clear?
Yes, sir.
Anything that you want me to explain again?
No, I'm out of this.
All right. Okay, then you also come across with some diagram questions. So I'm going to draw a cube. So that's your point O. This is your point A. This is point B, C, D, E, F, G. So the shape OA, B, C, D, E, F, G is a cube, and the side of this cube is 4 centimeter. The unit vectors I, J, K are parallel to OC, OA and OD in such a way that the vector parallel to this vector is I, the vector parallel to this vector is J, and the vector parallel to OD is K. Okay, so far is the question clear? Like whatever I've written so far?
Yes.
Now, there is a point M that lies on FB such that Fm is equal to 1 centimeter. There is a point N that lies on OC and is a midpoint of OC. Okay, so N is midpoint of OC. and there's a point P, that is P is the center of square face, DEFG. Point P is the center of this square face. This is what the question has given. Now the question is asking you express each of the vectors NP and MP in terms of I, J and K. So we need to find the vector NP. It's a cube, okay?
Yeah.
So, and it's a cube of side 4 centimeter. P is the center of this face. Would you agree that to travel from N to P, you can first from point N, you can travel in the J direction to the center of the face, okay, and from this face you can travel vertically up to P. Would you agree with this? You go in the J direction from point N to the center, right below the point P, and then once you reach this point, you go up to the point P. Will this give you the vector NP?
Yes.
Okay. So now my question to you is, how much units do you have to move from point N to the center of the square?
2 centimeters.
Two units. But now you're going to tell me in terms of I, J and K. So 2 units in the J direction.
Yeah.
Positive 2 or negative 2?
Positive.
Positive 2. So we haven't moved any units in the X direction. We have directly moved 2 units in the J direction. And then from this point, you have to go how much high?
4 units.
In which direction?
K.
K direction. That's why the vector NP in terms of Ij and K is going to be 2J plus 4K. Okay. Then what do we need to find?
And
We need to oh we need to find MP. Okay. So to find MP, M is basically on this line. So how do you plan on moving?
1 unit in the K direction, and then
One, okay, you are saying that I should go over here, then over here, and then over here. Is that what you are suggesting?
yes.
So I'm going to mark the arrows so that the path is clear. So to find MP, let's call this point any random point X. So first, I'm going to travel from M to F plus F to X plus X to P. Is that clear?
Yes.
Now, what is the how much do you need to travel in as MF?
1K.
1K. Okay. FX.
-2I.
Very good. -2I. Then XP
-2J.
-2J. That's correct. So you would always write the I component first, then the J component, and then the K component. This gives you vector MP. Okay. So this we did this using the by traveling parallel to IJK direction from the diagram. You could have also done this using position vectors as well. So it's going to be your choice. Any particular question over here?
No, sir.
Okay. Do you need to copy down anything or should I move on?
So you can move on.
All right. After position vectors, the next thing we are going to study is the concept of scalar product. You have seen how to add the vectors, subtract the vectors. Now, you can either multiply a vector by a vector. Okay, so when you multiply a vector by a vector, you get the resulting answer is also going to be a vector. But that part is now not included in this. So I'm going to leave the cross, that was called cross product. The other kind of product is known as scalar product or dot product. This is when you multiply a vector by a scalar. uh, yeah, it's like a, okay, let me show you. The answer of multiplying the two vectors result in a scalar quantity. Are you a physics student?
No, sir, no.
No. Okay. But let me give you one example. Acha. This is vector A and this is vector B. Whenever asked to find the scalar product or a dot product, this is how it's written. That's the notation. A dot B. It's known as the dot product. Okay. Now we are going to discuss some introductory ideas. If the two vectors are acting at some angle, okay, either this could be the case or this is radially outward, or you could have something like this where it's radially inward. So we are also going to take into account the signs of the direction of the vectors. So this is direction both away from a point, and this is direction both towards a point. And this is the angle formed between the two vectors. Now, as vectors have magnitude and direction, we can think of this scalar product as being multiplication in relation to a particular direction. What happens is that if this is a floor and there is a block lying over here, a man is pulling this block with a rope, so he's applying a force in this direction. But although he's pulling at an angle, although he is pulling at an angle, but the block is traveling in this direction. So the direction in which there is a pull is not in line with the direction of the object in which it's moving. This object is going to displace in this direction. The displacement is going to be in this direction, whereas the force was being applied in this direction. It was at an angle. So the amount of force being applied is going to be found out by taking the magnitude of the force. Now, if I were to ask what is the work done in physics, basically there's a concept of work done. Work done is the force applied in the direction multiplied by the displacement in that direction. So work is done by the person, that is equal to the force needed to pull that object multiplied by the distance the object moves. Now, if this diagram shows a vector F representing the pull and this vector D representing the displacement, you can see that the direction of the pull is not the same as the direction of the displacement. This means that only some of the force the person uses to pull the object makes it move. Not the entire force is responsible for moving the object, only the part of this force is able to move the object in this direction. So what we are going to do is we are going to find the component of the force that is responsible to move the object in this direction. Now, if you consider this, there's a right angle triangle being formed. Okay, so the force was mod of F. If I ask you what is this component, can you use trigonometry to find me this component?
Yeah, so
Let me call this x. So if I want to find x, I'm going to use cos theta equals to x upon mod of f. So x is basically magnitude of f times cos theta. That's why the horizontal component is f cos theta. This is the component of the force that is responsible for moving the object in the x direction. Now this force is a vector quantity. Although it's a component, but it's a vector quantity. So f cos theta multiply by the displacement. So if that is the vector, I can find the displacement magnitude as well. So work done is basically one of the example of a scalar product. This multiplication is one of the example of a scalar product. So if two vectors are dot together, the effect, the answer is equal to, if let's say this is if this is one vector A and this is the other vector B, so mod of A times mod of B times cos theta, that is an answer equivalent to the scalar product. So what you need to remember only is that when you dot the two vectors, the answer is equal to mod of A times mod of B times cos theta. I just want you to remember this equation. If the two vectors are being dot together, meaning the vectors are being multiplied in such a way that the result is going to be a scalar value, this is known as the dot product. The dot product is equal to the magnitude of the first vector times the magnitude of the second vector times cosine theta. Okay, now how do we calculate the dot product? So if I give you an example in which there's a vector p that is 8 minus 6 minus 10, and there's a vector q that is 4 minus 3, 0. ठीक है, and the angle between the two vectors, between them, is 45 degrees. I want you to give me, find the value of the scalar product or the dot product. Now you're going to use the above equation that the dot product between P and Q is going to be equal to the magnitude of vector P times the magnitude of vector Q times cosine theta. How do we, if I have the vector P, can I find the magnitude of the vector P easily?
yes.
How do I do that?
Square root 8 square plus 6 square plus 10.
Yeah, so square root times vector q magnitude, that is 4 square plus minus 3 square plus 0 square times cos of 45. So 8 square plus 6 square plus 100 square root 10 root 2, and this is 5, and cos 45 is root 2 upon 2. Yeah.
Yeah.
So if you multiply this, the answer comes out to be 50. which means that the scalar product of the two vector is 50. That is the answer. Okay, do you understand how do we do this?
Yes, sir. Could I copy down what's on this page?
Yes, sure. Yeah, just hold on a second. I'm gonna give you time. I just want to complete one more thing.
Okay, sure.
So we had vector p as 8 minus 6 minus 10, and we had vector q as 4 minus 3 0, right? And using this formula, p dot q equals to p mod q mod cos theta, the angle was 45 in this example. So the answer came out to be 50 using the right hand side. I just want to show you that using the left hand side as well, the answer should come out to be 50. And for that, you need to understand how to dot the vectors using the column vectors. So I'm going to use the left hand side. I'm going to write the vector p over here, 8 minus 6 minus 10 dot 4 minus 3 0. Now, when you are applying the dot product using the column vectors on the left hand side, what you do is you multiply the x component of the first vector with the x component of the second, the y component with the y component, and the z component with the z component, and add the products. So 8 times 4 plus minus 6 times minus 3 plus minus 10 times 0. So 8 times 4 is 32 plus 18 plus 0. So 32 plus 18 comes out to be 50. Okay, we were expecting that the answer of the scalar product is going to be 50. Are you with me so far?
Yes, sir.
Okay. Now I can give you some time to copy. The next thing that I'm going to discuss are the two special cases. Case 1 is when you have parallel vectors, and case 2 will be perpendicular vectors. Now, when the vectors are parallel, this is vector A and this is vector B. I've drawn the two vectors as parallel. So, and if they are in the same direction, what is the angle between the parallel vectors? What is the angle between the parallel vectors?
Um, 90?
That was for perpendicular. These are parallel vectors. If the two vectors are in the
180.
same direction and are parallel, it would have been 180 when the vectors would have been parallel and opposite. If the parallel have the same direction, not the opposite direction, then the angle is going to be 0 degree or 0 radian. Okay,
Okay.
0 degree or 0 radian. Now I'm connecting it with the concept of the dot product. So if I apply the dot product on two parallel vectors, okay, this was equals to mod of A times mod of B times cos theta. If the angle is 0, then what is the answer to cos theta, cos of 0?
1.
1. So would you agree that the dot product is just going to be equal to the dot product of the two parallel vectors is going to be equal to the product of the magnitude of the two vectors?
Yes.
Okay. And if the vectors would have been equal, like if A dot A, these are the two vectors, these are in the same direction. Okay, so this would simply means mod of A times mod of A if the two vectors would have been equal. Now, the other case is case 2 where you have perpendicular vectors. When the two vectors are perpendicular, What is the angle between them? 90 degree. So if the angle is 90 degree, let's see what happens to the dot product. A dot B is going to be equal to magnitude of A times magnitude of B times cos theta. Okay, so magnitude, if the angle is 90 degree and you plug in theta as 90, what is cos of 90? 90 or pi by 2, both works. So when you take angle as 90 degree, what is cos of 90 degree?
0.
0, and anything multiplied by 0 will make everything 0, right?
Yeah.
So the dot product comes out to be 0 when the two vectors are perpendicular. Now this is very important rule. You can say when the two vectors are perpendicular, their scalar product or the dot product is 0. And it is also true that when the scalar product is 0, the two vectors are perpendicular. So the question can be designed in such a way as well that they give you that the dot product is 0, so you know that the two vectors are parallel, or the question is going to have a statement saying that the two vectors are perpendicular, so you are going to take the dot product as 0. That is going to be the implied knowledge that the dot product is 0. Are you getting my point?
Yes, sir.
Okay. Okay. So the next question is that the position vector of A is 5 minus 2 4, and the position vector of B is minus 1 3 minus 1. The formula for the dot product helps you to identify the angle between the two vectors. Find angle OBA. Now be careful of these kinds of questions, because in these kinds of questions the direction of the vectors is going to play a very important role. A sketch will help you to make sure you choose a correct pair of directions for your scalar product. Remember, we did two sketches. Let me show you. These are the two sketches, taking the direction both away from a point or taking direction both towards a point. So when finding the angle OBA, let's make a correct sketch to help us find the correct scalar product. Angle OBA means that the angle is at B. So if I make a rough sketch, this is point B. Now I can call any of the vector as A and any of the point as B, any of the point as A. But to find angle OBA, which is this angle, using the concept of scalar product or the dot product, please be mindful that you take the correct direction. Either you are going to take both the direction as radially inward, or you could have drawn a diagram in such a way that both are radially outward. Both are either radially outward. To find the dot product, you must be careful of this, that both the vector directions are outward. So either you could have a scalar product of vector BO with BA, or OB with AB. Please try to understand this. To find uh, to find the angle OBA, you can either dot vector OB with AB, or if you would have gone for this diagram, this kind of sketch, you would have dot BA dot BO. इस बात का ख्याल रखना है आपने, ठीक है? The direction is going to play a very important role in finding the correct angle.
Yes.
Okay, so I'm gonna go ahead with this one. Okay, so in the question I do have OB ka vector but I do not have AB ka vector. What can I do with AB ka vector? I'm just going to erase this now. How do I find vector AB? Sorry?
OA minus B.
OB minus OA. Right? OB minus OA. So what is OB? Minus 1, 3, minus 1. OA is 5 minus 2, 4. You can find the vector AB easily. That is minus 6, 5, and minus 5. Minus 6, 5, and minus. Alright, so vector OB is minus 1, 3, minus 1. You dot it with the vector minus 6, 5, minus 5. I'm going to wait for you. Can you apply the dot product and give me the value of the scalar product?
Yes.
Okay, so when we solve this, you get 26 as a dot product. All right. Now, this dot product OB dot AB was equals to the magnitude of OB times the magnitude of AB times cosine theta. And we need to find this angle theta now. Let's find the magnitude. We know that the answer to OB dot AB is 26. So we are done with the left side. Now the magnitude of OB is just going to be minus 1 square plus 3 square minus 1 square square root 9, 10, 11 square root of 11, and the magnitude of AB is going to be 6 square plus 5 square minus 5 square, which comes out to be 36 plus 50, 86 cosine theta. With me so far?
Yes, sir.
All right. Now you need to solve this 26 divided by square root of 11 times square root of 86 and take cos inverse, find the angle theta.
Uh, 32.29.
32.29. So in one decimal place, it is going to be 32.3 degrees. Correct. Now also be careful that whenever it's an observation that whenever your dot product is a positive value, you are always going to have an acute angle. When the dot product is a negative value, the dot product could be negative as well. Whenever you have dot product as negative, you're going to observe that the angle theta is going to be obtuse. Is this clear?
Yes, sir.
Okay, hold on for a minute. I'm just going to take out some past paper questions. All right, please try this question. All right, so in this question, relative to the origin O, the position vectors of the point A, B, and C are given as the following. You need to find angle ABC. To find angle ABC, be careful of the direction of the vectors that you take. Just make a rough sketch. Since you want to find angle ABC, you can take angle AB and then CB. Okay, so you understand the directions, right? Radially inward or radially outward? So the two vectors that you are going to play with is vector AB. Vector AB is OB minus OA, that is 4, 2, 3, minus OA 2, 3, 5. Calculate AB for me, and similarly vector CB is going to be OB minus OC.
So AB is 2, minus 1, and minus 2.
2, minus 1, and minus 2. Okay. Now vector CB is going to be, so minus 6, 2, and minus 3. Is that what you are getting?
Yes, sir.
So I need to find the angle ABC. So that is going to be AB dot CB equals to magnitude of AB times magnitude of CB times cosine of theta, the angle. Okay. Now AB is 2 minus 1 minus 2. I'm going to dot it with minus 6, 2, and minus 3. Work out the angle, work out the magnitude of AB for me. The magnitude of AB is going to be 2 square plus 2 square plus 1 square. 9 square root of 9 is 3.
Yeah, 3.
Yeah. 6 square plus 2 square plus 3 square root of 49 is going to be 7. Okay. You need to show the working, okay? So 3 times 7 times cos theta. Let's find the dot product as well. Minus 12 minus 2 plus 6. I'm getting the dot product as minus 8. So what was the observation? That if the dot product comes out to be negative, the angle is going to be obtuse. Okay. So minus 8 divided by 21 cos inverse theta comes out to be 112.4.
112.4.
Is that clear so far?
Yes.
Now, the second part to this question says that the point B is such that ABCD is a parallelogram and you need to find the position vector of D. Now, if ABCD is a parallelogram, then vector AD must be parallel to vector BC, or vector AB must be parallel to vector BC, parallel and equal as well. So these two vectors must be equal. So AB vector must be equal to vector DC. I do have vector AB, right? That is 2 minus 1 minus 2. DC vector in terms of its position vector can be written as OC minus OD. What was OC vector in the question? 10, 0, 6. Now you can just solve this for OD. So OD vector, the position vector of OD is going to be 10, 0, 6 minus 2 minus 1 minus 2, 8, 1, and 8. Okay.
Yes.
Any questions so far?
No, sir.
Should I move on?
Yes.
Try the next question. So now this question says that OA and OB in terms of position vector are these. You need to find the value of OA dot OB and hence state whether the angle AOB is acute, obtuse, or right angle. To answer this, the first thing that we are going to do is we are going to dot the two vectors. 2 minus 8, 4 dot 7, 2 minus 1. So 7 times 2 is 14 minus 16 minus 4. So what do you get? 14 minus 16 minus 4 should be minus 6. So minus 6, the dot product is negative, therefore the angle is obtuse. If this would have been positive, the angle would have been acute. And when do you think the angle would have been right angle when the dot product is? When do you think we are going to have a right angle?
When it's
When the dot product is going to be 0. If this value turns out to be 0, then that means that the two vectors are perpendicular, which means that they are at right angle. ठीक है? Is it okay now?
yes, sir.
Now the point x is such that ax is equals to 2/5 of ab. Find the unit vector in the direction of ox. To find the unit vector in the direction of ox, let us first find ox. Ax is 2/5 of ab. Ax can be written as ox minus oa. AB is going to be OB minus OA. OX needs to be found out. So 2/5 of OB minus 2/5 of OA plus OA, 2/5 of OB plus 3/5 of OA. You have OB vector as 7, 2 minus 1, 3/5 of OA, which is 2 minus 8, 4. So 14 upon 5, 4 upon 5, and minus 2 upon 5. ठीक है, plus 6 upon 5 minus 24 upon 5, 12 upon 5. So when you add them up, 14 plus 6 is 20, 20 upon 5 is, see, you need to add the two vectors, simple vector addition. So 20 upon 5 is 4. 4 upon 5 minus 24 upon 5 is going to be minus 20 upon 5, which is going to be minus 4. And minus 2 upon 5 plus 2, 12 upon 5 is going to be 10 upon 5, which is going to be 2. So that's your OX vector. But the question didn't only ask for OX, it is asking for the unit vector of OX, which is OX vector divided by OX magnitude. So I want you to quickly find out the magnitude of OX.
6.
16 plus 4, 36, 6, yeah. So 1 over 6 times OX, which is 4 minus 4, 2. Now if you simplify this, you are going to get, अच्छा, in terms of ijk तो नहीं बोला, ठीक है? They have, you can express in any form, either in column form or ijk form, that's up to you. So 4 upon 6 is 2 upon 3 I, minus 4 times 1 upon 6 is minus 2 upon 3 j, plus 1 upon 3 k. Either you can express answer like this or in the column vector form, up to you. Clear?
Yes, sir.
You need time to note this down?
No, I have it down.
All right. Now I want you to do one diagram question before I end up the class.
Okay.